everyone. Welcome to Medix's last deliverable. We hope that you have enjoyed watching the progress of our product. If you have been following our previous presentations, you might recall that the team decided to create the Medix AI thorax disease detector, which is a thorax disease detector. Enjoy the presentation. Today, we will cover a recap of who we are and the project we chose. It includes team members, roles and responsibilities, improvements, project description, team working agreement, and personas, followed by a project overview, which covers the MVP, languages and tools, algorithms, diagrams, and a Sprint 3 recap. Next, we will look at the backlogs, including product backlog, Sprint 1, 2, and 3 summary, Sprint 4 backlog, test cases for Sprint 4, and story completion. Then we move on to team metrics, and we'll look at the team velocity, burn down charts, and the retrospective. Lastly, we'll showcase the new and improved product. We have added many features to it. In this section, we will look at the application screenshots, API, and live application demo. We have 8 members on our team. We are self-organizing, cross-functioning, passionate, and hardworking. The Medix team members are Ronaldo.S as a Scrum Master and developer, myself, Marla Capistron, as team leader and database administrator, Filippo Zaloco as a developer, Christopher Ospina, another developer, Anthony Munoz as a quality assurance tester and developer, Liana Machado, another developer, Raul Nayanegali as a developer, and lastly, Prithvi Raimanya as a designer and developer. We have all committed our time to this project and are pleased with how it turned out. Everyone played a crucial role in its development. After each sprint, Professor Wong gives each team insightful feedback. This feedback allows us to improve our presentation and project. The improvements we have made for Sprint 4 are: we renamed the Sprint 4 workload to Sprint 4 backlog. We provide explanations for the burn down charts. We also include an assignee for each task and user story. And lastly, an improved order of conducting the retrospective. You will notice a yellow star is placed on slides where an improvement was made. The problem today is that currently X-ray machines are widely available. However, clinical X-ray images can be challenging to read and diagnose. Furthermore, X-rays are not a priority for radiologists, as they tend to focus more on CT images and MRIs. CT scans are both harmful and expensive, in addition to being time-consuming. And so our project, the Thorax Disease Detector, is a web app that has a highly trained deep learning model that classifies X-ray images, reducing the need for a radiologist to examine them. It is intended for medical professionals and patients who upload X-ray chest images. It uses a deep neural network model that will detect common health issues rather than having to wait for radiologists to examine these X-ray images that are not a priority to them. Our application will reduce the time it takes for the patient to receive their diagnosis using AI. Some of the benefits from utilizing our application are faster physician response rate. It is cost-effective, reducing the need to hire more professionals. Its use of AI reduces human errors and efforts. It partially automates the chest X-ray review process. And lastly, it improves physician workflow. The team working agreement was created during Sprint 1 to lay out expectations in order for the team to have a smooth and successful transition of the project. We committed to being transparent, accountable, honest, being proactive, and taking initiatives in tasks where a member's skill is capable. And above all else, prioritizing the success of this project. This document outlines the team's communication, participation, meetings, and respect, which ensured the success of the project and each team member. All members followed this agreement, and it is evident in this presentation as well as the product we created. And now Anthony will take it from here.
Thanks, Marla. So, as a patient, you rely on medical professionals. You get checkups, health advice, and recommendations for procedures such as x-rays when they're deemed necessary. However, people are busy with their daily lives trying to balance work and family, so it's hard to schedule appointments, not to mention follow-up visits that may be required. The time taken to get results, depending on the procedure, can be a challenge in itself because it might take a long time. So you manage to make your follow-up, you sit down with the doctor, and can still come out of that consultation with questions. So using our chest X-ray AI solution, patients will be able to get the results faster. They could view results on a website that's easy to navigate. And lastly, a patient could see a doctor's comments about the result right away, allowing a patient to understand right away without scheduling a follow-up for another in-person visit. So now we come to radiologists. So healthcare facilities are currently facing unemployment and are in need of modern equipment. Due to budget cuts and the rising cost of medical school and the debt that comes with it, not many people want to specialize in radiology and wait until they're 30 years old to start their careers. This leads to clinics suffering from a lack of applicants. In addition, the current number of radiologists isn't enough to train recent medical school graduates and accommodate the growing volume of patients. These challenges are the root cause of burnout and long shifts, which leads radiologists to think about whether or not they want to stay in the profession. And the nature of the job requires radiologists to work with sensitive cases such as cancer, which directly impacts their ability to tend to all patients equally. So we found that a chest X-ray AI solution can alleviate the workload by automating the detection of known chest conditions. This would allow radiologists to concentrate on their more complicated cases, improving their overall workflow. Next slide, please. So doctors have a large volume of patients with limited time for consultations. Doctors sit with patients and explain what the diagnosis is, but patients can leave with questions that they look for answers. They look for their answers online, which can lead to greater confusion and anxiety about a diagnosis. So our chest ray solution allows for a doctor to communicate with the patient by leaving comments about the diagnosis that explains the results clearly. This would help build a strong relationship between the doctor and patient as well. Next, please. So we started our product design by collecting ideas from each of our teammates. We gathered the designs as shown here on the slide and picked the parts from each design that we liked. So after that, we discussed color palettes and agreed on a final product design. Next slide, please. So this is what the final product would look like. We'll have features such as uploading the x-ray, getting the results that come with a description of what it is, along with a doctor's comments underneath. You could also see the x-ray ID, a progress bar that lets you know when the image has been fully reviewed, and an option to download the report for your own personal records. Next slide, please. So what you see here is our MVP design. We used Figma to visualize this. As you can see on the right side photo, there's an option to browse and pick a file or drop and drag an X-ray image. On the left side, you can see that after uploading the X-ray, this is the result that we expected from our MVP. And this is something that we've gotten from since Sprint 2. However, we have been able to exceed this expectation, which will be shown later in the screenshots. Thank you. And now I'm passing it on to Rahul.
Hey, thanks, Anthony. So today we are going to dive into the cutting edge technologies powering our medics. And at the core of this application lies a powerful combination of programming languages, frameworks, algorithms, databases, and tools all are working together seamlessly to deliver accurate and efficient medical diagnostics. So before we delve into the specific, let's take a moment to highlight the technologies upon which Medex is built. So firstly, programming languages and frameworks. So these are the building blocks that enable us to create dynamic and responsive user interfaces as well as robust backend system. So next is algorithms. So at the heart of Meddex lies a sophisticated deep learning algorithm that leverages the power of AI to analyze medical images with accuracy. So database. Secure and efficient data storage is crucial for our application, and Firebase enable us to manage and retrieve patient information and medical records seamlessly. So and tools lastly. So to streamline our development process and ensure seamless collaboration, we have selected a suite of powerful tools that enhance our productivity and workflow. Next slide. So now let's explore programming languages and frameworks that power Medex. So we have chosen powerful combination of HTML, CSS, JavaScript, Node, uh, Tailwind CSS. Right. So these are the front ends at which our Medex app leverages and to build dynamic user interface. Next slide. So for the backend, uh, Python's microframework Flask is used to render the chest X-ray findings along with a very friendly description, right? Not patients can't understand the very complex medical terms. So, so along with the finding and friendly description is delivered by a Python Flask API. So moving on to databases, we have integrated Firebase for secure image storage and API access. So Firebase is used to store uploaded images and provide an endpoint to call the API. So tools. Efficient collaboration and streamlined workflows are essential for any successful project. Therefore, we have meticulously selected a suite of tools to optimize the development process. Firstly, Figma, which facilitates design collaboration, enabling seamless contributions to the overall development process. VS Code, which serves as a primary code editor, providing a robust environment for coding tasks. And GitHub, so which is utilized for remote version control and collaborative development, ensuring efficient team collaboration. And Docker, so which simplifies deployment across various platform, which makes us platform independent and streamlining the deployment process. So Insomnia is employed for API testing, ensuring reliability and functionality of our APIs together. And all of these are all open source tools we are using. So all these tools enhance our productivity and enable smooth project execution. Next slide. So here comes algorithms, right? So let's dive deeper into the intricate details of a deep neural network. So neural networks are usually composed of interconnected layers that process input data and transform it into meaningful outputs. So our neural network demonstrates key components of training a neural network model on the expert data set for multi-label classification of chest X-ray images. So the the scale of images we are driving is around 200 plus K images, chest X-ray images. So our model integrates various layers, each with a specific role. We have convolution layers, which are like filters that help us detect important patterns in the X-ray images. So these patterns could signify various abnormalities or any dangerous conditions a patient can have. We have also incorporated batch normalization, which ensures stability and accelerates the training process. So another layer which we have included is dropout. So which is an essential component, strategically dropping out some neurons during our training, which helps us prevent model becoming too reliant or learning too much on the training data, which is also called overfitting. So this reduces the overfitting. And regularization plays a crucial role in controlling the complexity of a model. It helps prevent our model becoming too intricate, right? Which could lead to poor generalization on unseen data, that is validation of test data. So to optimize the training process, we utilized ADAM algorithm, So ADAM is an adaptive learning rate optimized algorithm that adjusts the learning rates for each parameter individually, resulting in a faster convergence and better performance. So now what makes our model even more robust is extensive training data it has been exposed, right? So we have trained our model using a data set consisting of 200 cases which are already highlighted earlier. So this vast amount of data ensures that our model is learning diverse patterns and provide reliable diagnostic insights. So with this combination of technologies, Medix aims to enhance medical diagnostics, offering accurate and efficient solutions to improve patient care. With this, I'll finish my part. Thank you. Handing over to Preet.
So thank you, Rahul. Thank you for this explanation of technologies. Now we are going to understand the our Medix AI more deeper. So we have three main entities in this, which is doctor, patient, and radiologist, where doctor and radiologist comes under medical professional. So these three entities will directly interact with our AI tool, which is Medexer, to upload and receive the reports. So to understand a context of it, here it is a context diagram where you can see a doctor will be uploading the image to the tool, when tool with the magic of its AI will generate a report and uh, receive the report. Doctor would be able to receive the report. So would be the same by the patient, and so would be the for the radiologist. So on the next slide here, we can see that there's a class diagram which explains how we are going to manage our internal database uh, through these classes. So as I said earlier, there are four main entities: patient, X-ray, hospital, and medical professionals. So in patients table, we are going to store all our patients information such as name, email address, passwords, etc., their profile images. That's what we are going to save in. So and in the medical professional side, we are going to save their professions such as doctor and radiologist, their name, email ID, and so on. In the X-ray table would be all the information regarding all the reports generated from our AI, and this will all be linked with one hospital that we're gonna that the Medexer is gonna work under. On the next slide, we are gonna understand how these entities are interlinked with each other. So let's say in an hospital, a medical professional such as radiologist or a doctor is working, and he uploads an X-ray. So that would be the property of hospital, and the medical professional would produce the report through our Medixer AI by uploading the X-ray and then sending it to the patient. And patient would be having these reports also from their side verified by a doctor. So on the other side, the patient can also directly upload the report, upload the image to the Medixer tool, and on the other side, the medical professional can review those and give a certification whether everything is right or wrong, or whether our tool was correct or not. And then patient would be able to receive the reports back again with the current comments and views. So this is how all the entities are interlinked with each other. On the next slide, we are understanding that how our software architecture is. So in the beginning, the user will be seeing the front end through its user interface, which was created using React and Tailwind CSS. And that will be directly interacting with our backend, where we used Firebase and Flask server for our backend, where uh, our neural network model is running with the TensorFlow within our server. So when user on the front end request something, the request will go into our backend through our Flask server, which will generate our report, and all that report data would be submitted on the backend side on the Firebase. And we are using Firebase tools, as Rahul explained earlier. And all of these, to simplify, we have containerized this whole application into a Docker. So this would be the sequence of the activities. So let's say a user uploads the X-ray. The website or our web app, Medixer AI, would receive the uploaded image and will then send it through our Firebase API to the Firebase storage. Firebase storage will generate an X-ray document with image URL and X-ray ID and resend it to the front end part of the React. And then from front end, it will go back to our MedXR tool, which is basically our Flask server generating with neural network model, generating the image analysis by downloading it on a local environment and sending the results back to the Firebase. Once everything is stored in the Firebase, the front end will again pull all the data from the Firebase and show it to the user. So this is how user will be able to see the report. This is a little bit of state of our app. So user logs in, he selects an X-ray file and uploads it. The X-ray file would then show as a pending. If X-ray is uploaded where it matches the conditions such as PNG, JPG, all that conditions that we have put in inside would be accepted, and then it would be classified into whether it's reviewed or not reviewed. If it's reviewed, it will be sent back to the user. If it's not reviewed, it will show user that it is still under review. And finally, after all this, user will be able to manage its states by logging and in the end, logging out. All this data would still be there with the user's database management from Firebase APIs and Firebase storage system. So after understanding all of this, I'm gonna tell you a little bit about what we did in Sprint 3. So first thing we did was we added the search bar and optimized it more by providing information such as date, report ID, diagnosis, and status. So whenever a user is trying to search something, he doesn't have to enter all the information. He can enter one of those and can find multiple options to go for. Once the report were added into the table, there were minor errors which we were not able to do in the Sprint 2, but in Sprint 3, we added a great functionality where the history reports can also be viewed, and all of the data was primarily available for use. Then once the report has been generated and submitted to the doctor could now comment on the report by Sprint 3, and users were able to receive those comments. So once this comment was done, the status of that X-ray would be changed to successful, or it would be saying review. And we were able to optimize our login feature as well, and also the UI was improvised later on in Sprint 3. Once the report has been generated, we provided the functionality to download and print the report at the same sessions. Also, there were problems where the user only wanted to view the reports which were most recent. So on the dashboard, we provided the functionality that whatever has been the latest change would display on the dashboard. So let's say whatever the last uploaded report would be displayed to the user, or doctor's comment has been made on the previous report, that would be shown, that would become the recent report, and that would be shown to the user. And in the final steps, what we did is the neural network we earlier used for the study and to work on it, it had a touch of a previous expertise. But now, once understanding everything, we could create our own neural network, and then this self-developed neural network was later on added to our system and replaced by the older one. Finally, we completed all 33 points that we promised in Sprint 3, and that was it. Thank you, and now handing over to Chris.
Thank you, Preet. This is Chris, and now I'm here to discuss the project backlog. As you can see, we've completed simple or required tasks in the past 3 sprints, such as training the basic neural network model with the NIH dataset in Sprint 1, and creating database tables with Firebase in Sprint 2, And in the last sprint, we Dockerized the front end and back end for cross-platform and machine compatibility. In the previous sprint, we also fulfilled requirements for the back-end development process, such as integrating the model with the API, learning how to perform CRUD operations with the Firebase, and creating a static login page to test its functionality. Now we will go deeper into the project backlog to explore estimation values, user stories, and corresponding features to previous and current tasks. Let us take this generic radiologist's user story from Sprint 2 and say that he or she wants to provide a quick and automated X-ray results for common chest health issues to allow more time to be dedicated to the analysis of lesser-known health problems. This is why we tailored the medics are featured to allow radiologists to study lesser-known lung diseases. And we gave this an estimation value of 13, depending on the importance of this feature and whatever user story that goes with. Now let's take another example from our current sprint. Patients who we assume know nothing about medical terminology would want their diagnosis explained in language that they understand. For this reason, we added the result description and gave that a score of 8. There are also other user stories that we took care of pertaining to our registration and login features in this particular sprint. Let's take 2 examples each from any prospective patient or doctor users. It's important that both of these types of users register and store their personal information so that they can access certain data. For patients, their medical records and allowing private connection with doctors, and for doctors, vice versa. And as for the login features, it's important we have them so that both patients and doctors could securely access their information. Patients have unique access to the profile feature, which we've just added in this sprint. And let's just say that a patient wants to update their personal info if it were to change, like get a new doctor, legally change their name, get a new address, or get a new phone. So for that reason, we tailored the profile feature so users could store up-to-date information if in need of emergency or the need to be reached urgently. Now here's Liana.
Chris. Based on each user story, we describe the acceptance criteria, which represent the conditions that must be satisfied for the user or feature to be accepted. This was done using the structure of being given a prediction. When something happens, then there is a result. For Sprint 2, these were the conditions that we met. If a radiologist, doctor, or patient wants to upload an X-ray image through the image upload feature, when they open the Medix AI web app, click on the upload button and select an image file or drag and drop the image file. Then the application will store the image for processing. In this scenario, the criteria our web app satisfies is being able to store an image file for processing. And moving on to the next slide, please. Another acceptance criteria the team had met during sprint. The previous sprint is for the web app to provide a diagnosis or finding for the X-ray provided through the Medix or feature using AI. When a radiologist or doctor uploads an X-ray image, then the application will classify and provide a quick diagnosis, and then they will be able to access the result. For Sprint 3, we worked on the doctor notes feature, which provides a text box message section for each report to allow doctors to post comments for the patient to see. This is a form of communication between the doctor and patient for any extra information that would need to be mentioned. Next slide, please. Another criteria we met in the previous sprint is a reviewed status feature, where a patient can view a status file reporting if a doctor has verified the X-ray result and updated the report when they click on any of the patient's reports. Also, the criteria for the web app providing a text description of the X-ray finding classified in a selected report was satisfied during Sprint 4. Next slide, please. Some other notable criteria we met during Sprint 3 are for Medx AI to be able to download report files to the user's local system. We plan users to have a history of past reports available, which are stored in the cloud during the Sprint 4. Next slide, please. When the user logs into Medx AI, then the dashboard page is displayed with the most recent X-rays. Following that, a notification feature is added in Sprint 4 with the criteria of alerting the user of a change made to their report. Next slide, please. In Sprint 3, the web app is available to access reports using multiple identifiers to filter, including an X-ray ID, report date, and status, for the search feature to quickly locate specified reports. Next slide, please. For Sprint 4, users are able to have profiles where the criteria is for the Medx AI to store user credentials so that users, either radiologist, doctor, or patient, can create their own account to securely access patient information. Next slide, please. Along with the profile feature, the web app is expected to have a login and logout system for medical professionals and patients. When opening the app, the user is then prompted to log into their account with their credentials and click the logout button to end the session. Next slide, please. With a login and logout system, Medx AI is expected to create and store accounts where a medical or Medx ID is used for physicians and personal emails is used for patient accounts. Next slide, please. Lastly, the team is expected to meet the profile criteria in Sprint 4, which we did, which includes patients to upload profile information and store the changes in the database. When a user goes to their profile and clicks the edit button, profile information includes their name, address, and phone number. All the conditions I have described must be satisfied for that user's story or feature to be accepted and considered done. Next slide, please. Now, looking back on the work the team has done throughout the previous sprints, we began by figuring out a problem that we could find and develop a valuable solution to, with the health sector being the topic we settled on. We then came up with a team name, Medx, which relates to the thorax disease detection solution we plan to develop. In Sprint 1, we self-organized and established team roles based on the skills we had and what we wanted to learn. The team also got familiar with the topic domain and researched the literature to understand user challenges. We brainstormed how AI could be used as a solution and designed our team logo. After determining what type of application the team will build, we designed wireframes and prototypes of the app. We also researched what technologies we would use to develop our product. So moving on to the Sprint 2, the development of the app began here, where the team focused on the two main features of the web app, which are the image upload and the Medx. Ronaldo and Filippo worked on the image upload feature, where a patient or medical professional would be able to submit or drag and drop an X-ray image file to the database and for the access to have further access to it on the web app. Rahul worked on the AI part of the solution, which provides quick diagnosis results based on the X-ray image uploaded. Sprint 2 had a total of 35 story points. Through the burn-down chart, we can see that in the beginning of the sprint, we relatively followed the ideal velocity. However, by the middle, we were behind the ideal velocity, but we managed to meet up to the ideal velocity around day 17, where we went ahead of schedule and were able to complete all of the story points by day 24. Following that, we go into sprint 3, where the team worked on a total of 33 story points. Prithvi, Ronaldo, Filippo, and I developed the doctor notes feature for comments to be added to patient X-ray reports. The reviewed status feature was worked on by Prithvi, which showed whether a doctor had verified the X-ray report or not. He also worked with Chris on the feature for users to download the reports, and then with Ronaldo on the dashboard to display the latest X-ray report and the search feature to browse for a specific report. During sprint, the born down chart, we can see that generally we followed the ideal velocity with in the beginning going a little bit ahead of schedule and slightly behind schedule. And towards the middle, those two bumps where we can see we fell behind schedule a little bit, then met the ideal velocity, and then again fell a little bit behind, and then met the ideal velocity up until day 18, where we managed to successfully meet all of the story points. And I'll be passing it on to Mala.
Thank you, Leanna. Sprint 4 was our final sprint, and we added several features to our product. We provided the patient with a result description. This result description is essential to the understanding of a diagnosis, as it provides the diagnosis in a user-friendly way. We have also allowed patients and doctors to view their reports as a gallery. This gives them an ease to track their health issues. Furthermore, we have even added a notification bell icon. When a little purple dot appears next to the bell, a patient or doctor are informed of an update to the account. For example, a patient's notification might be a doctor's comment, whereas a doctor's notification might be that a report has been added to the database. Moreover, in the event we have new patients and doctors and they need to register, we have now added a registration and sign up page. The login and logout function is now fully functioning. Doctors and patients must enter their credentials to sign in. And lastly, a profile update page was added to allow users to update important information. As we worked on Sprint 4's backlog, we created test cases to ensure each new feature was working properly and our application was running as intended. We aligned these cases to user stories, which are indicated by the user story ID, as well as the feature being tested. You will also see that each test case has a unique test number to keep track of all the test cases. For this project, we came up with a total of 32 test cases from Sprint 2 through 4. For example, when testing the login and log out feature, we used email and password. Some of the test cases included using an incorrect email, which triggers an error message, and we also used an incorrect password, which triggered another error message. We also tested the registration and sign up page, and we were able to successfully create a patient and a doctor. Furthermore, we tested using duplicate email addresses, and this triggered another error message. We even did a test case in which we left fields blank, and this told the user that they must fill out the fields. Additionally, when using the registration page, we provided an incorrect or invalid email address, and that triggered another error message, which told the user that they forgot an @ Next, when we came up with test cases for the profile, we used the information from Firebase. We tried leaving some fields blank, and it told the user to please fill out the field. And when we came up with notification test cases, there was a message with the associated report ID and the date and the type of notification, whether it was a doctor's comment or that a report has been uploaded. For the result description, this is the test case that is important for the patient, as it provides a friendly definition of the medical diagnosis, and it is working properly. Each time a diagnosis is provided, the user-friendly definition is also displayed below the medical term. And now I'll hand it over to Ronaldo.
Thank you, Marla. Okay, so here is the Spring 4 story completion. As you can see, there's a table with 7 columns with the estimation points, the user story ID, who will be benefited with this feature, what I want, and what I'm trying to accomplish, the feature, and the status. As you can see, we have 5 features on this table, and the estimation numbers are followed by using Fibonacci numbers, meaning that the highest that you go are the level of difficulty. So as you can see here, there's 4 features with 5 labeled with as a 5, meaning that it was a little bit harder than the one with decimation point as of 2. And those features are result description, report history, and there's 2 features for that one for patient and doctor too, and then 2 for notification for patient and doctor. And as you can see, we have completed all of those features as of now, and Sprint 4 has a total of 44 story points. Moving on to next, thank you. So as you can see, we have 5 more features here with almost all of those features have an estimation points of 3. So those features were the following: the registration and sign up for 3 users, a medical professional, which is a doctor, radiologist, and the patient, and then 2 for the logging in and logging out, which are again for the patient and the doctor. And as you can see, we have also completed those as well. So okay, and then the last 3 are for patient and doctor, which are part of the logging in and logging out for patient and doctor with an estimation point of 3 for those 2. And then the last one, which is the profile page, where the patient can update their personal information, and that has an estimation point of 1. And the status are that we have completed all of those. And if you sum all of the features that I listed in the past, there is a total of 13 features with a total of 44 estimation points. On to next. Okay, so the team velocity for this sprint was 44 story points. Okay, moving on to next. And then here's a explanation of the burn down chart. So as you can see, we have 2, one for sprint 2 and one for sprint 3. For sprint 2, you can see that there were a few days when we started on day 1 that we were ahead, and then we kind of like went into this big bump, and then we stayed there for 3 or 4 days, and then we kind of like were going on to the ideal line by day 16, and then we went ahead for from day 17 until day 24. That's where we made the ideal line for sprint 2. So we managed to have everything complete by day 24. And then for sprint 3, we started ahead for the first 2 days, and then we fell off for one day, and then we stayed at the ideal line, and then we were ahead for a little bit, and then we went on to this pump for a few days where we kind of like didn't do work, and then we were closely following the ideal line, and then we stopped the game for a few days, but then by day 15 we picked it up to speed, and we met the ideal line on day 18, which we have everything completed by that that day. Okay, so the rundown chart for sprint 4. So we pretty much were ahead almost all of the time. As you can see, since day 1 we were ahead, meaning that we have already finished what we promised. So that's pretty great. And then you see on day 6, that's where we met the ideal line, and then we were just keep going, and then we were ahead, and then on day 18 we met on the ideal line. But like this sprint, we like it's been shown that like we had worked like the hardest, and like everything is uh paying off. Okay, next. Okay, so this is the average burden chart from sprint 2, 3, and the last one, which is 4. And you can see but on like first we are ahead, and then we met the ideal line, and then there's this little bump until day 15, which means we kind of like were slacking a little bit, but then we were doing work, so that it's kept the same until where we met on the ideal line, which is by day 16, and then we worked ahead until we met the ideal line again by day 19. Okay, so this is the completed committed ratio for this sprint for all of the 3 sprints combined, 2, 3, and 4. So as you can see, for sprint 2 we have the 35 estimation points. For sprint 3 we have 33, and for the last one we have a total of 44, and that gives us an average of 37 points with a 100% completion. Okay, moving on to next. Okay, so this is a screenshot of the retrospective. As you can see, there's 3 columns: what went well, marking green; what needs to be improved, marking orange; and the last one, action items, marking light blue. Moving on to next. Okay, so this is the retrospective. What went well? Pair programming sessions with live share on VS Code. That was great. We coordinated ourselves and helped someone when they were overwhelmed. We did continuous communication updates through WhatsApp, and we create soft deadlines. What needs to be improved? We need to avoid scheduling meetings late at night. We need to we stay on a call for the duration of the meeting, and then we need to create subtasks for broad user stories, and we need to specify the length of the meeting at the beginning and minimize the length of the meeting as well. And then some of the action items are 3. As a team, as a team, agree on the length of each meeting. Share team members' schedule to let everyone know when you're available and when you're not, and create meetings for pair programming slash code review on a separate general meeting. Okay, moving on. Okay, so I'm gonna explain the following code snippet, which this is included on the MetaXer. So this function handle predict takes an image URL as a parameter and sends a request to a local server endpoint, which you can see on line 92. And then while it waits to receive a response, it attracts and prints the prediction name and description. It also updates the components, states, set finding, and set description with the prediction details. Lastly, it redirects the user to a report page with the prediction data. If an error occurs, the error is printed and sets the loading to the loading state to false. Thank you, and now I'll pass it on to Filippo.
The following is a series of screenshots representing the user's journey across the application and the software engineering that made the MedX project possible. We begin with the login page, offering two options, signing as a doctor or as a patient. Upon clicking either option, the page prompts the user to enter their credentials, email, and password respectively. If a user doesn't have an account, they can choose to sign up by clicking the sign up button below. We can see that in the registration pages, the user is required to provide their account detail, including full name, email, confirmation email, and password. If the user is a returning user, on the other hand, they'll be redirected to the login page upon clicking login. After successfully logging into their accounts, the user will land on the dashboard page where they can see their latest report, featuring report ID, date and time, condition, definition, latest update from a medical practitioner, and status bar, which can evaluate to reviewed or reviewing. In this case, report 20 has been reviewed. Moreover, upon clicking on the user icon at the top left, the user can choose to log out and sign back in as a different user. The Medexer page, the user can upload or drag and drop an image in the formats of .png or .jpeg, and we also included a test case for when a file that isn't compliant with those two formats is submitted, the code will return an error, asking the user to try it again with the specified formats. In the report page, we find a list. We find that an X-ray has been uploaded and that the user has the option of submitting said report. Once clicking on submission, a message will pop up saying that the report has been submitted. And now there is a list of reports in ascending order from 8 to 19. Some are reviewed and some aren't. We also added a feature in the report page, but it is applied across the application too. And that's the identification of reports through the search bar. Upon entering dates, report IDs, conditions, or status, we can filter all the reports that we want to see. Next slide, please. In this slide, we can appreciate that report 4 has been identified and displayed in the under results in the report page, displaying that its status has been updated to reviewed. We also have the option to print out a report by clicking the print button. And here is how a PDF of the report will look like. The report page will look different depending on the user. As a doctor, you have the option to update a comment and add it into the report. As a patient, you're displayed the report message. Click that close my door, it's going to get like amazing. Next slide, please. Um, and here we can see that a doctor comment has been added and that the application returns an alert window. In the doctor's view, we can see that in the report notification, you have the option to log out and sign back in as a different user. What that has shown to the left, you can see the report date, the status of the report, the ID, the time, and the latest comment. Next slide, please. In this slide, we showcase that both doctors and patients have the option of updating their profiles. They can enter different emails, change name, update the date of birth, gender, and contact information. To make our project possible, we worked with Firebase, a Google technology that is built on NoSQL database. Every time that a user, like a medical practitioner or a patient, uploads an image, this image is converted into an internet format that can be read by the database. We use the components ref, get download URL, and upload bytes to allow this. And every time an image is submitted, a URL generated by a Google API is captured and then used later by our neural network to fetch data, image, and analyze it. Next slide, please. To run the neural network, we used a Python environment 3.9, which runs in a Flask application. To expose the API without interfering with the package JSON on the front end side, we use the API course, which was then we will then use it in the front end too to fetch the response of the neural network. As you can see to the left, we have the response function, which listens the function from the front end, from the back end, that returns a classification output. Next slide, please. In order to work across platforms and to support the continuous development and integration of our code, we use Docker. Docker is part of our application architecture because it allowed us to run the backend and the front end separately in specific Linux instances. We use a version of Linux that supports a Python application for the backend and a version of Linux that supports a Node application for the front end. In Sprint 2, when testing the backend and the neural network, we could see that the neural network was returning outputs at incredible speeds, 53 milliseconds, sometimes 125 milliseconds. But we were using a neural network that wasn't 100% or even close to 90% accuracy. And we decided not to sacrifice quality over speed. Hence, we adopted a neural network built by by researchers at the University of Stanford that returns outputs in a consistent manner between 135 milliseconds and 178 milliseconds with a 93% accuracy. Next slide, please. This is a snapshot of the Docker containers running in one of our machines. Each container exposes a port, which for ease of use, every user will just have to click on those ports, such as 3000 and 3000, to use the application, and the port 5001 and 5000 to test the API. Here is a demo of our application.
Today, we will present the last live demo of the Medex AI application by showcasing its newest features. In our first video, we were able to upload an image and view the preliminary result. In the second video, we showed the functionality of the search bar, viewed the report status, added a doctor's comment, and printed the report. In this last demo, we will show the registration form for signing up as either a patient or a doctor, login sessions for both users, notifications for when there are updates on reports, a profile page, report history, and a friendly result description. As mentioned in the first video, the thorax disease detector is a web app that has a highly trained deep learning model that classifies X-ray images. Let's begin. The login page will show an option to log in as a doctor or a patient. Depending on the type of user, the user will choose the correct login for themselves. We will log in as an existing patient. And then after, we will log in as a doctor. As you can see, there are two input fields required in the sign-in. The patient must enter their email and password. We will use Angela Fernandez's user credentials. For security purposes, we have added an additional layer of security to the password. A user can view the inputted password by clicking on the eye, and then can click it again to hide it once more. Once both credentials are filled in, the user can click on the login button. Once logged in, it will automatically take the user to the dashboard. This is where the last session of the report can be viewed. In this case, we are logged in as Angela Fernandez. We are now viewing her most recent report, which includes the finding, date, report ID, and doctor's comment. In this case, we see that the doctor has not reviewed her report yet, and it's displayed by saying reviewing. The next step after our dashboard would be the Medexer tool. This allows the user to upload an X-ray chest image by dragging and dropping an image onto the Medexer tool, or by clicking on the Browse button to select the image. For this video, we will use the Browse button to select an image. Once the image has been selected, the user must submit the image by clicking on the Submit button. Soon after, they will see a loading screen, which indicates the image is being analyzed by the neural network model, and within seconds, the result page is displayed. Angela's diagnosis is atelectasis. We can also see a Submit Report button. When we click on the Submit Report button, a unique report ID is generated, and the report is submitted to the database and to the doctor's portal as well. A message pops up displaying that the status of the report is reviewing, and then its unique report ID, which in this case is 9. Once you click OK, you are redirected to the dashboard page. As you can see, this report is given the report ID of 9. Additionally, there is a review status bar showing reviewing, meaning that it still has to be validated by a doctor. In order for Angela to view her past reports, she can click on either the Report tab or use the search bar. We will be using the search bar to demonstrate. As you can see, there is an existing report listed, showing the report ID, diagnosis, reviewed status, and date. Angela might even want to look up her reports by date. In this case, she can type in the date of her report into the search bar. Right, as you can see, she has one report for May 6th, 2024. Furthermore, Angela can use the search bar to look up reports viewed and validated by doctors. When she types reviewed into the search bar, it lists all the reports that have been reviewed. When she types in reviewing, it lists all the reports that need to be validated by a doctor and pending for validation. As a quick glance of all reports she has submitted, Angela can click on the Report tab. The reports are shown as thumbnails with their respective report ID, diagnosis, and report status. When clicked on, you will see the report details. At this time, Angela may choose to print this preliminary report. However, it still needs to be validated by a doctor. In order to print the report, she will click on a print report. In the print window, one can see that the status of the report is reviewing, meaning that the report has been submitted to the database, but a doctor has not reviewed it yet. Consequently, a doctor's message is missing. Once a doctor has reviewed the report, their message will be displayed. And here is an example of a printed report. We have Angela. We have report 9 with Angela's name, atelectasis, the friendly definition, the medical term, and a report status of reviewing. Angela may wish to update her personal information in the application to ensure she isn't missing anything important. In order to do so, she will click on the profile icon and select the profile button. Angela may update her name, date of birth, sex, contact information. Once she is satisfied with the updated information, she will click on Submit. A pop-up message will appear, letting the user know that the information has been updated. After clicking OK, the user may choose to close the application or log out. We will now log out. Now that we have viewed the user interface as a patient, we will now see it from the perspective of a doctor. This time, we will log in as an existing doctor. As you can see, the same two input fields are required to sign in. We will use Patricia Norman's user credentials. The same level of security is seen in the doctor's portal. The user can view the inputted password by clicking on the eye and clicking it again to hide it. The dashboard looks almost identical to that of the patient. However, the doctor is viewing the most recent report updated to the database. The doctor sees the report ID, diagnosis, a doctor's message, comment section, as well as the reviewed status bar. This report still needs validation. Just like the patient, a doctor may upload an image, and to do so, they would click on MedXer. The report gallery for the doctor shows all the thumbnails for their respective report ID, diagnosis, and status for every patient. This can be daunting to sort through when there are so many patients. So when trying to find a report for a specific patient, luckily the search bar allows the doctor to search a report by ID, medical term, or date. The doctor can filter the reports by date, only viewing the reports for a given date. In this example, the doctor is viewing the list of reports for April 8th. The doctor may also type in a medical term. And view a list of all the reports with that specific diagnosis. In this case, we are seeing that there are 2 reports for lung opacity. Furthermore, a doctor can use the unique report ID and type that into the search bar. Report 8 gives us lung opacity as its diagnosis, and one can see that this report still needs reviewing. Lastly, a doctor can filter the reports by report status, distinguishing between reports that need validation versus reports that have been validated already. In order for a doctor to validate and provide a comment, the doctor needs to select a report. In this case, the doctor will click on the report that we have uploaded as a patient earlier in this video. He may do so by clicking the report shown in the search bar or by clicking the gallery. As you can see, this is report 19, and it is now displayed on the doctor's portal. Once the doctor is viewing the report, they may provide a comment. So please contact me. Before updating the report, they would click on update report, and a pop-up message will be displayed indicating that the comment has been submitted. Once the doctor has validated the updated report, they will automatically be taken to the dashboard. The doctor's message is now displayed. Please contact me. Additionally, the status of the report is now changed to reviewed. Upon closer inspection, you will notice that the bell icon now has a purple dot next to it. This indicates that a change has been made. When Dr. Norman clicks on the notification icon, she will see that the report has been updated. It gives her the report ID, the time it was changed, the report status, and the comment she just provided. A doctor may also choose to update their personal information. But before we look at that, let's look at the notification that the patient gets. So on the left, we are seeing Dr. Norman. And on the right, we are seeing Dr. Norman, and on the right, we are seeing Angela Fernandez, our patient. You will see that there are 2 little purple dots, one on the doctor's side and one on the patient side. If we click on the doctor's side, you will see that there is the notification of the report ID that was changed, the date, the report status, and the comment. Now let's look at the patient. That little purple dot for the patient's side shows the same thing, the report ID that was changed, the time, the date, how the report status was changed to review, and the doctor comment that Patricia Norman provided. we will now look at how the doctor and the patient can update their personal information. And they will do so by clicking on the profile icon and then the profile button. As you can see, they are able to change their name, their date of birth, sex, and contact number. Now we will log out from both the doctor and the patient.
Okay, you can continue.
Let me make it bigger, like full screen.
Sorry.
Lastly, imagine you are a new patient and would like to register. We will walk you through the sign-up process now. If a patient is not an existing user, we will show you how to register. The first thing a new patient would do is click on Patient in the login screen. And then they would click on Need an Account, Sign Up. When signing up, the patient would have to fill in these required fields. They must include their name, email address, confirm their email, and create a password. We're going to make a patient called Hector Lopez, give him an email address, confirm his email address, and a temporary password. Once all of the fields are filled in, he would press sign up. But before that, if he wants to view the password he just typed in, he would click on the I to reveal what he just typed in. And then he would click on sign up. If the patient has followed all the registration requirements correctly, a little pop-up message comes up. It was green and it happened really fast and it said signed up successfully. Furthermore, they are redirected or they are directed to the dashboard. To confirm that they have successfully created their account, they would click on that profile icon. And as you can see, we are in fact logged in as Hector Lopez. Now, let's create an account for the doctor. No, go back. Now, let's quickly show what happens if a new patient tries to register using an existing email address. So let's see what happens. We are going to use Maria Barrios. And she's going to use Hector's email address. Let's see what happens when Maria Barrios tries to use an existing email address. When she clicks sign up, right, she gets an error message. Password must contain an uppercase letter. And it also said this email address is already in use, meaning that two patients cannot share the same email address. In order for Maria Barrios to create her own account, she must use a different email address. So now Maria Barrios is going to put her email address with a different password. Yep, she can click on the I to reveal her password. And she is directed to the dashboard. If we quickly look at the profile icon, we are now logged in as Maria Barrios. We will log out. And now we will attempt the same process, but this time for a doctor. There is a disclaimer for the doctor. In order for a doctor to register, they must be provided with a certified hospital email address. And once they have an accepted email address, they may follow these steps. If they do not, they will be unsuccessful. So now we have clicked on the login for doctor, and we will click on need an account, sign up. When signing up, the doctor would have to fill in the required fields. Again, they must include their name, their email address, confirm their email, and create their own password. In this case, we are creating an account for Bryce Ruiz. If the new doctor has followed all of the registration requirements, once they click sign up, again, that same pop-up right on the top right, it's green, it's small, and it goes by super fast, and it says signed up successfully. Furthermore, they are directed to the dashboard, and as you can see, this new doctor has report 9 displayed in their database. That was the last report we uploaded as a patient, and Dr. Bryce is seeing it on his dashboard. This is the latest report. And now Dr. Bryce can verify the reports in the database and provide comments. To confirm that we are in fact logged in as Dr. Bryce, we're going to go ahead and click on that profile icon button, and we see that it says Bryce Ruiz, and then that we can sign out, log out. To build this current version of the MVP, it took our team 4 sprints. We continuously used Figma as a collaborative design tool. We updated and improved the existing code in Visual Studio Code. This concludes the demo for the thorax disease detector. I hope you find this application valuable. Thank you.
Now let's talk about future enhancements. First, we're going to allow users to update their emails through their profile page, followed by the addition of a chatbot for user assistance. And third, confirmation by email after successful sign up. Next, we're going to forward the notifications to the user's emails. And we're going to display the top 3 diagnoses of each report by probability value. We will then try and increase the accuracy of the convolutional neural network built by the researchers at Stanford. And finally, we're going to conduct live tests of our applications at selected clinics. And we're also going to provide the ability to schedule an appointment. Here is a link to our wiki page on GitHub. Thank you for following our presentation. I hope you found our solution valuable, and stay tuned for further updates from the team. Thank you.